and definitely not least keynote you have today, is Steve Brewster, which I would like armfully thanks for the efforts, the double, triple, many efforts he's doing for delivering these keynotes. We know that it's the end of the conference. Everybody is a little bit tired, and also maybe suffering from the weather and the hot. And okay, so I know that not easy for everyone. So I hope that you'll be here to the end for very interesting questions related to multimedia, haptic, and auditory design. So Stephen Brewster is professor at the University of Glasgow in Scotland. Everybody knows him for many, many years. He's one of the pioneers on interaction techniques using haptics and different combinations of multimedia input. I couldn't speak 1 hour about all the things, the nice things he has done. And even more recently, he has a series of ERC grants from Europe, which is a kind of outstanding recognition that funds the research of highly recognized researchers like Steve. So thank you very much, Steve. The floor is yours because you have much more interesting to say than me. And I will be back for questions later on.
Thank you, Marco. Thanks for inviting me to talk about some of the work. So as Marco says, I'm from the University of Glasgow in Scotland. I'm going to talk about a project that's just coming to the end now, which is all about passengers. So within HCI, people have thought about drivers and all sorts of other users, but nobody had ever really thought about passengers and the interesting things that we might be able to do for passengers. So the aim of this project was to kind of investigate this untapped area. Just like Judy did, we have to also thank the Distinguished Speakers Program from the ACM who supported my travel to the conference here. So the project is called Viajero. I'm not sure if that is in Portuguese, but anyway, in Spanish it means traveler. So the sales pitch for the project was that it's going to radically improve passenger journeys by facilitating the use of immersive virtual and augmented reality to support entertainment, work, and collaboration when on the move. So basically using virtual reality, augmented reality to try and change the passenger's experience. So if we step back in time, maybe this is the view of travel from the 1950s. So we've got three people in the car, traveling down this highway into a futuristic city. The two people in the front have rotated their chairs, so they're looking at the person in the back. If you can see on the table, it looks like they've got a nice cocktail or something like that. There's a screen between them. So that was the view of how we might be traveling back in the 1950s. Has that turned out to be true? I don't know. Sometimes my travel is a little bit more like this, especially when my kids were small. You know, it wasn't such a relaxing place. Or maybe, on my way over here, I had an 11-hour plane flight, and if you're stuck in an economy row seat and you're trapped in, you can't escape, perhaps it's not quite as nice as that 1950s view was. So maybe there's something we can do to make that traveling experience better. So what we're going to talk about is supporting traveling experiences with XR. XR is just the combination of virtual reality and augmented reality. So if you think about journeys, well, yeah, kind of often they're a repetitive and waste of time. If you think about your commute, maybe you commute to work in a bus or a car every day. It's kind of boring, it's just the same. Maybe if you think about autonomous cars in the future, maybe that might be even more boring because at least you have to drive in a manual car, but in an autonomous vehicle, you won't even have to do that. Oftentimes, we have quite limited access to technology. Maybe you've got your phone or a tablet, or maybe on a plane, you've got the seatback display, but it's nothing like being in the office where I've got two big monitors or at the movie theater. So the thing we're looking at in the project is, well, how could we improve entertainment, productivity, and collaboration when you're traveling? So oftentimes you want to be entertained. You want to watch movies or do different kinds of things like that. Sometimes you need to work, so how could you work better? And then how could you collaborate with other people who maybe traveling in different places to you. And then there's three main research challenges I'll talk about. The first one is around interaction. So one problem you're always going to have is that you're going to be in a small space. Whatever type of transport you're on, you've got a seat and you don't have a lot of space. A lot of virtual reality applications, for example, might want you moving around, sword fighting with aliens or doing all sorts of things, but you can't do that in such a small space. There's a lot of issues around social acceptability because you're using that headset in amongst many other people. And then they have social expectations of what people will do in that environment. And if you're kind of half out of that environment because you're in outer space or swimming with dolphins in a beautiful virtual reality world, then that has social aspects too. And then a big one behind it is also motion sickness. So a lot of people get motion sickness right now. If you're reading a book, what's in a car, my youngest daughter gets quite bad motion sickness. Many people get that. If you're wearing a VR headset, for example, it could make it even worse. And then all these nice things I've talked about that we could do, well, they're not an option. So, potential benefits. We could alter or augment or replace the physical space around us. So you could make your environment more interesting, maybe adding extra things into an augmented reality environment, or replace it entirely with something better. So maybe I'm on my economy plane seat and I change the whole view of what I can see with my headset so that I'm in outer space. Maybe then I don't feel so crammed in because I can't see the other passengers, I'm in outer space, or I'm swimming with dolphins and having a nice relaxing time. I might also appropriate elements of the reality that I'm in. So for example, maybe I can use the seat back of the seat in front of me to do something. I've got armrests on the chair, so maybe I can use some of those things. Maybe I can use other vehicles around me on the road. I can use those as part of an augmented reality game. And then maybe I can also use the sensed motion from the vehicle that I'm in to change my XR experience. So for example, maybe I could make my 30 miles or 30 kilometers per hour journey feel like 100 kilometers an hour, maybe make it more exciting. So let's have a look at a few examples. So here we are. Here's entertainment first. So maybe I really like to watch a huge cinema screen if I'm on a plane, rather than just watching my phone. Or maybe I want to play an immersive game where I'm totally surrounded by the environment. So here's one. This one is not mobile, but here you can see two people sharing this virtual reality cinema. So one of those could be on a plane, one of those could be my wife back at home. We could be sharing the cinema experience, but I've got a huge IMAX-sized screen. I'm not tied to my phone, I've got a huge screen. This is just pixels. I can have whatever I want. Well, here's a gaming version. So here we're driving in a car around the front of the university where my department is. The direction of your spaceship is controlled by the motion of the car, and then you're shooting the aliens. Now remember, in the UK we drive on the other side of the road, so Mark is not driving the car, he's the passenger in the car. So the car motion is controlled by the spaceship motion is controlled by the car motion, but he can then shoot inside that. So taking advantage of the vehicle that you're in to drive the gameplay. Maybe we want to think about work. Well, in my office I've got two nice big screens I can work on. The best I can generally hope for when I'm traveling is a laptop screen. Oftentimes I'm writing emails on my phone. Well, I like those two big screens. It lets me have a lot of documents open, see a lot of context on what I'm working on. So why can't we do that when we're traveling? So here's an example of a VR workspace. This was a project we did with Logitech. So the keyboard that's in there is a special one that can be tracked in VR. And then you can register it with a virtual model. So you can see the keyboard, type on a real keyboard, but in VR. And that works super well because typing on the keyboard is the best form of input that we've got. If you've ever used a VR headset, and mostly you're raycasting to letters of the alphabet, which is a really super slow way of typing, or trying to type in the air. Using a real keyboard is better. So here's an example again, driving around the front of the department. So this time we've got the documents in front of us and we can look at those. So they're not being controlled by the motion of the car, because that would be rather annoying, because if my document was here and the car turns, then my document is behind me, then I can't see it. So what I really want then is to be stabilized in my view. And you can see some of the electronic stuff on the dashboard there. All that is part of a little piece of hardware we put together to be able to separate the car motion from the sensed motion in the headset. So then you could be working on your documents, they're in front of you, I can have multiple windows open, I can make it more like my office environment. Or finally some collaboration. So it could be working or playing with somebody else nearby, or in the same vehicle as me, or it could be somebody else far away. Here's a couple of examples. This is me and Katrina in our car, and we're taking a virtual bus tour, but we're both in the same shared environment. So in a minute you'll see the bus starts to move. The red building in the background is the Central Station in Glasgow, so it's a bit like doing one of those open-top bus tours around the city, and you get information about the buildings as you drive around. So there we are, there's some information on the side of Glasgow Central Station. Or then, of course, we could be playing the game together. So now we're both playing the game, and the motion of the vehicle is driving the motion of our spaceship. So potential interesting things that might make our travel time more interesting. But there's a few problems that we have to resolve before we can do that. As I mentioned before, one of the big ones is that whatever form of transport you're always in a kind of confined space. If I'm in a car seat, I've got a bit of space, but I haven't got too much. In my economy seat, well, I've got the seat in front of me. If the person reclines it, then I don't have a lot of space. So whatever form of transport you're in, it's always quite small. And as I said before, a lot of VR applications anyway would require larger movements. Doing those large movements is not going to make me popular with the people sat next to me if I'm sword fighting in my game and there's somebody in the seat next to me. I'm going to be punching them. So I need some way of maybe mapping the larger movements into smaller ones so I can use small movements to control this application. Or maybe I can use something about the physical environment to help me there. And then, as I mentioned before, social acceptance is important because the kind of things you might do in that environment, like doing sword fighting or waving your arms around, is going to make you look pretty weird, and maybe then people wouldn't want to do that because it just looks embarrassing. So here's one of the first projects we did. So one of the advantages that you have as somebody in economy class is that it's very easy to reach the seat in front of you. Mostly you might not consider that an advantage, but sometimes it's an advantage. So what we were looking at is, well, could we use that seat in front of you as an interaction surface? The idea is that I could use that as what's called passive haptics. I can touch on that surface. It's a real surface. It's really solid. I can touch on that. And if I register that with a virtual reality application, then I can pretend, or it feels like I'm touching on a real solid thing. So what we did was think about how we could use some of these things for input. As I said before, typing in VR is pretty terrible. Either I have to raycast to all the letters I want, which is very slow, or I have to try and do mid-air typing, which is very difficult because you get no clear feedback about when you've pressed a key. Unlike when you tap on a keyboard, you know when you've pressed it. So what we did here was we used the seatback and the tray table as interaction surfaces to see what would work. If you're familiar with it, we did a kind of Fitts law task. Looks a little bit like the European Union flag. So what you had to do was touch on one of those yellow targets, drag to one of the other targets, and then release. So we had a bit of tapping, we had a bit of dragging. Very kind of typical interactions that you might do. So this idea of passive haptics. So now when I'm tapping on one of those yellow dots, I'm actually pressing against something solid, and I'm dragging on something solid. So we compared that just tapping and dragging in midair, and unsurprisingly, is much better to be able to tap and drag against a solid surface. It feels much more like real typing when you do that than when you're kind of doing that, where you don't ever really know if you press the key. So significantly improves all the tapping and dragging operations. Much less errors, much easier to do, improves agency, self-location, reduces workload, all loads of really great things. But the disadvantage was, and we compared the seat back and the tray table. The disadvantage, particularly with the tray table, was that to use the tray table, you have to look down like this quite a lot. And after a period of time, people's necks were hurting and they were complaining about neck strain. So we could use the tray table. That came out to be the best in terms of the input, but the neck issues made it uncomfortable for a long period of time. So what can we do about that? We use this idea of perceptual retargeting. So what does that mean? So if you look at A in the picture, there's Thomas using the seat back. And then in B, all that we do is move the visualization of his hand higher up. So his hand is still really in the same place, but in VR, he sees it higher up. So he no longer has to look down to where his hand is now. He can look up here, even though he's still tapping in the same place physically. You can see the tray table 1 is in C. Then we rotate the tray table up a bit to D. So again, your physical hand is in the same place, but your virtual hand is a bit higher up. Same task as before, the tapping and then the dragging. And what we found was that this works pretty well. Most of the time, for small manipulations of your hand position, you can't really tell. It's a bit like the mouse, really. You know, you move the mouse here and it moves on the screen. Seems okay. So most of the time that worked pretty well. If you change the display by about 45 to 60 degrees, it was good for user comfort, and the neck issues went away. So I don't have to be looking down like this. I can rotate it up a bit. So I'm looking more straight ahead. And that was really good for user comfort. Didn't affect the performance. Worked really well. No neck issues. The problem became is if you rotated it too far, once you got up to maybe head height like that, then people started getting confused because the manipulation of your hand then moved the virtual hand in a kind of weird way. So they got very confusing. So smaller rotations or smaller manipulations work well, the larger ones less well. But even with smaller ones, we solved some of those neck issues. So that's called perceptual manipulation, really, or perceptual retargeting. I'm changing what I'm seeing compared to what I'm doing with my body. So we then decided to take that a little bit further on another part of the project. So here, what we wanted to do was alter the perceived motion of the vehicle. So I mentioned before, maybe I can make my trip seem more exciting if I'm driving at 30 miles per hour, but if I can see that I'm driving at 100 miles an hour through my augmented reality headset, maybe that's more exciting. So I could apply gain, or maybe I could apply attenuation. Maybe if I'm going very fast, I might want to make it feel more slow, because maybe that's more relaxing. So maybe I could add excitement to a boring journey, or to be slow things down to be more relaxing. So we did two tasks here, a reading task and a gaming task. But I'll show you what it looked like first. So here we have driving along the road. Are you playing? Driving along the road in Glasgow. This is a street near the university. We're driving at 50 kilometers an hour. And what you can see in the windows at the bottom, that's the two views of your VR headset. We had a text comprehension task. So people were reading some text and answering questions about it. So in this case, they're driving along at 50 kilometers an hour, and what they're seeing in the headset is presented at 50 kilometers an hour. Doesn't cause you motion sickness, because the things you're seeing are the same as what you're experiencing. But in this case, we've got some different speeds. So going from the left-hand side to the right-hand side, we're increasing the speed. So the right-hand side one is 350 kilometers an hour. So I'm driving along at 30, but I'm experiencing 350 kilometers an hour speed through my headset. So the interesting thing with this one is, maybe for the first two steps of this, I couldn't really tell. It feels exactly like the movement of your vehicle matches what you're seeing. So that was up to about, I think, about 120 kilometers an hour. I couldn't tell the difference there between what I was feeling with my body and the motions of the car and what I was seeing. Clearly, when I got to 350 kilometers an hour, I did not feel like I was going at 350 kilometers. But about 100, yeah, I couldn't tell that I wasn't going at that speed. It was kind of an interesting experience. Then, of course, we went the other way, all the way down to walking speed and 7 kilometers an hour. In some ways, for me, when I was experiencing this, this felt somehow weirder than going faster. When the car is driving along at 30, but you're seeing very slow walking speed, yeah, it was quite, it felt quite strange. So what we got people to do was this reading task, so we could see, did being in this different speed of motion, did that affect their reading performance? And actually, at some points you can. When you're going very fast, maybe there was a lot of distraction. But certainly we could change the speed by some factors, and people didn't even notice and didn't affect their text comprehension. Here's another version. So this one is a game. So we'll play the video of the game. So here you're flying along in a copy of the trench run from Star Wars, but with a dog instead of R2-D2, so make sure we didn't get sued by Disney. And what you can see there is it suddenly starts changing speed. So different things are happening in the game, and the spaceship speeds up, it slows down. All the time your car was driving along at 30 kilometers, it was just driving along at the same speed. But we're using this kind of perceptual manipulation to change your experience. You get the idea. So after all that, the faster speeds, the faster speeds made the journey feel more exciting. So if you're on a boring journey, you can make it feel more exciting by doing that. Interestingly, people perceived the distance they traveled was greater. Everybody always went the same speed. They were just going at 30 miles an hour along the road, but people thought they'd gone further when the speed was faster. They also thought that the time they'd spent traveling was reduced. So you can imagine there that some manipulations you could do which might make you feel like your long plane journey was over more quickly, or you were getting to your destination faster. So that was very good for gaming, and people enjoyed that. The things that worked really well is that when the accelerations and the decelerations of the spaceship did match the decelerations and accelerations in the car. So, for example, if the car came and stopped at the traffic lights, and a red traffic light, when the traffic light went green, if the car acceleration then matched the spaceship acceleration, that felt fantastic. It felt like you were jumping into hyperspeed then. So the match then was really good. But even when you weren't matching it, it felt fine. For the slower speeds, they were definitely more calming, felt more relaxed. People said that they would prefer to do productivity tasks there because you haven't got stuff flying around all the time and distractions out the windows. The rest of the world is moving very slowly. It'd be good for kind of mindfulness tasks as well. We did one final bit of work in this area, looking at rotational manipulation. So that one there I was talking about was mostly speed manipulation. We were driving along the road and you make your virtual speed increase or decrease compared to your real speed. So here we were looking at rotations. So you can see the setup in the top left there. We bought a gaming chair which you can rotate on different axes. And we had the same kind of shooting game as you saw before. We did it in the chair, then we did it in a real car. So the interesting thing there was how little I really understand my own body. So what we would do was we would rotate people a small amount, but visually they'd rotate a large amount, or we'd rotate them a large amount physically, but they'd only see a small amount of rotation in the screen. It is impossible to tell. So I could do a 360 rotation visually, but if I only did like a 90-degree rotation physically, I couldn't tell. The craziest one was when physically I would be rotated one way, but visually I'd rotate the other way. So initially I thought, that's just going to make everybody sick. That's a crazy thing to even try. But when you did it, nobody could tell. So, but I know my body. I know what my body's doing in space. Turns out, no, nobody does. When you're controlling your own movement, you do. But when your movement is being controlled and you're only moving passively, it turns out you have much less understanding of what your body is doing. In fact, we can rotate you the opposite way to what you see, and nobody could tell. So then the craziest thing of all was this picture on the bottom right. It's a little bit hard to see. Let me get the pen. So this little bit around here, you can just see there's a little black area just there. So what we did in this one was we got people in the car, physical car, driving them around in that small black area just nearby the university. So that's the physical route they did. Then the red route is the route that they saw in the VR headset. You can see those two things are not very similar, but people couldn't tell, including, for example, I shouldn't use red. Red is a kind of an inconvenient color, isn't it? Let's try black. Including just here, for example, where they did a 360 turn visually, but not a 360 turn, obviously, in the car driving along the road. So people couldn't tell. So what that allowed us to do, for example, was make a straight road curved, or a curved road straight, and people couldn't tell. So the nice thing about being able to control those things is if you want to make a game, for example, that you want to play when you're in the vehicle, you're not constrained to the kind of roads that you're on. What you can do is you can manipulate what they see. People won't notice. People didn't get motion sick in this case. So we could control what they see, and it's not the same as what they're physically experiencing. So if I wanted to make a game where I could explore a world, I'm not limited by just having to go where the road goes. I can control what they see and change their whole experience. So that for me was completely crazy. That particularly I could not tell when my body was rotating in one direction, but visually I was being rotated in another. It's such an interesting experience and gives us such a lot of then design flexibility. Okay, let's think about something a little bit different. Next up, we'll think about social acceptability. I've hinted a little bit about that before, but it causes potential issues constraining our design a bit. So headset use is not very common in everyday social settings. We don't see them very often yet. But we may be using them in a vehicle alone, in which case that's probably okay. We may be sharing it with family and friends, in which case I could be doing weird stuff and they probably don't mind. But if I'm on a bus and I'm surrounded by people I don't know, then they might think, well, what is that guy doing? That's completely crazy. Or I might think, oh, I don't want to do those kind of things because that's embarrassing. So we wanted to look at, well, how should we design these kind of displays and things that you have? How should we design those? Where should they be located, for example? Where should the displays be? What kind of interactions could you have with them that would be socially acceptable? And an interesting thing about what information from the real world is needed. If you think about putting on a VR headset on the bus, and you're in outer space, flying a spaceship in outer space, and somebody walks on, sees you're in the headset, steals your bag, and walks off, and then when you come out of outer space, you think, oh, all my stuff has been stolen. So there's maybe things you need from the real world to make you feel comfortable about being cut off from it in a virtual reality. So here's a few examples. So the first thing we started to look at was, well, where would people want to put displays? And this is just in augmented reality, they're pixels. I can put the displays wherever I like. There's no limitation. So this is a kind of example scenario. We got people to do it in VR, but this is basically augmented reality, really. So they tended to put the screens, in this case, on the back of the seat in front of them. Yeah, makes good sense. They could put them anywhere, but they mostly stuck them to the back of the seat in front. Here's another one. This is an example subway. And this shows one of the two kind of classes of people that we saw. So here, the person's arranging their displays. And what they're doing is kind of blocking off all the other people in the environment. I don't want to see any of those people. I just want to block them off with other screens. Maybe in the old days that would be holding a newspaper and not seeing anybody else in front of you. Maybe it's different in Brazil, but the most important thing in the UK is never to look at anybody in the eyes when you're on the subway. So you have to look somewhere, you never want to talk to anybody. Maybe everyone's more social here. But so we called this shielding. So people kind of build a wall of displays, same way as opening a newspaper to block things out. Here's an aeroplane one. So the aeroplane one's interesting. Well, what would you do if I had screens in an aeroplane? Well, I'd just have the same screens as I would have in my office. Yeah, but actually people didn't want that because the bit of screen that's here is in this person's space. That's not really my space on a plane. If you're on a plane and the person's staring at your screen all the time, get out of my space. So what actually people chose to do was stack the screens vertically because that vertical space, that's mine. Over there, that's yours, and that's yours. This bit here is mine. So people felt much more comfortable having displays stacked vertically than horizontally. Now this is what we called avoidance. So we had the shielders who put the screens blocking everybody out. But there were also the avoiders. So what you can see there is somebody who's put displays on the table in front of them between the other people. Bit more where you'd put a magazine or maybe a laptop right now. One thing that came up was that if you put a display in front of somebody else's face to block them out, what that really means is potentially you're just staring straight at them for 11 hours on a plane flight or something like that. They don't know that you're not looking through the cameras and seeing them. They don't know what you're doing. So many people found that kind of socially uncomfortable. So then they avoided that situation by putting the displays down on the table. I think here's an example of an avoider in the subway scenario as well. So they put them out of the way. So we saw different types of people behaved in different ways, which suggests that maybe there's not one size fits all solution to where you should put the displays. You've got to give some flexibility. So that's display. What about input? So what we decided to do was see what kind of inputs people would find acceptable. It's going to wait. No, it's not going to let me do that, is it? Oops. So what we had here was in the middle you can see our student. She was composited into some virtual reality scenes. And what she's doing in those scenes is a whole load of different types of interactions. So we just thought of all the different things you could possibly do. Foot tapping, doing things on your palm, tapping in midair. Yeah, she's got a smartwatch-based interaction. So we just made up all these different types of interactions and put them in this virtual environment and got people to look at them and say, well, what would you think if you were doing that or you saw somebody else on the train doing that? There you are, she's using the typical VR controller. What's she doing? Something on the armrest, tray table. So all the different kinds of things you could imagine doing. And we tried it in some different scenarios as well, so maybe a little bit hard to see on some of those. But we tried lots of different scenarios. For example, where the train is, I'll just stop that. Where the train is, where you've got a table between you and the other people, or you've got your own seat, like in an aeroplane. Or sometimes there's trains where the other people are very close to you. There's no table, so you're sitting here and then there's people sitting there. And found that the environment has a very strong effect on social interaction. Now, obviously, if you were doing what that lady in the picture there is doing, and there's somebody sat there, then be waving the controller right in their face is not very socially acceptable. So those face-to-face seating layouts affect acceptability a lot, because you're doing things right into the space of the other person. So those mid-air interactions were less acceptable. Doing things on your body, so we had things like interacting on your leg. People didn't really like that. That felt a bit weird. So, but things where you use the controller in a closer to yourself way, or seat back if you were in that scenario, those things were very acceptable. So the environment you're in changes the types of interactions you might want to have or might be allowed to have in a kind of social way. So I think the interesting thing there is that, I can put pixels where I want because they're just pixels, but yet I can't because of social issues. There's many different types of interactions I could have, but I can't do them all because of those social issues. So there's a lot of interesting things there that come into play when you're trying to design those kind of interactions. It's not as easy as you think it should be because there are a lot of social constraints. And also, we didn't do too much of this, but you could imagine that there's different social constraints in different cultures. Maybe doing some of these things in Brazil will be different to doing them in the UK. Right, the last thing to think about is motion sickness. Again, I mentioned this at the beginning. Anybody here get motion sick? Quite a few people. And believe me, we can make all of you motion sick if we try hard enough. So, many people get motion sick reading books or using phones and tablets. The key thing really is, actually, it's not fully understood why it occurs, but the most prominent theory is that if I'm reading a book in a car, my eyes are still focused on the book, but my body's experiencing all the movements. And that's different to cyber sickness, because in cyber sickness, my body is still, so I'm sat at home watching a big movie screen or using a headset, and the things in the movies are moving. So I'm watching a car chase, and I'm seeing motion, but I'm not feeling motion. So those things are very related. It's the idea between this visual and vestibular mismatch. My eye sees something, but my vestibular system perceives something different. Immersive content could all make this worse. Has anybody tried a headset and has felt cyber sick? A few people, yeah. Some people get it straight away. It gets a bit better over time because the headsets are getting better, but still, many people get it. About 20% of people get cyber sick using a headset. So if you combine that with, they say maybe about 30% of people get motion sick, depending on the routes you're going on. So if you combine those two things together, you start to get a big problem about using VR headsets and AR headsets in moving vehicles. Immersive content can make it worse because maybe I don't see anything of the outside world at all. And this kind of content I showed in this little video at the bottom there, at the beginning, is when I fix the displays in space, then I'm likely to get more motion sickness because my eyes are fixed on those displays, but my body's feeling the motions of the vehicle. But that's very convenient because if I want to watch a movie, I don't want the movie to be behind me when the car's turned, so I need that content in front of me. So for a lot of games, for a lot of Word documents, for a lot of movies, you want that thing in front of you and to stay in front of you as the vehicle moves. So we spent a lot more time on my project doing motion sickness than I thought we would at the beginning because it turns out to be an interesting issue. So there are two parts. I'm only going to talk about one just because of lack of time, but if you want to know something about the other, I can tell you. So the first thing you need to do is detect when motion sickness starts. Some people don't get motion sickness. Don't need to worry about them. Some people get it very quickly. Some people, it builds up over time. So you need to be able to detect when it starts. And then what we did quite a lot of work on that, but what we did more work on was how to mitigate it, how to stop it if you start to feel sick. And if we can't do that, then it becomes hard to use these immersive displays. But the advantage with an immersive display is that we control all the pixels that you can see. So then we can do interesting things with those. So we can use some of those for techniques to mitigate the motion sickness. Now, we don't want the mitigations to be too distracting. I mean, one thing you do now, you often see in games, is that if you want to move in the game, the view shrinks down to a porthole, you move, and it opens up again. That's a very common way of moving in VR games and things like that. But that cuts you off from the content and is distracting and disturbing. So here's our first example. We'll get the chair rotating. So here, we're using the rotating chair again. And here they were doing a maths task in a window. This is basically a window in front of you. Now, if the chair was rotating and the display was fixed to you, as it rotated, it would stay exactly the same place. If it wasn't fixed to you, as you rotated, you would leave it behind. So this is a kind of halfway between the two. So we rotate the display in the direction of your movement, but only a smaller amount. So you don't have to rotate it 90 degrees if you're rotating 90, you just rotate it a bit less. So you can still see it doesn't go out of your view, but because it rotates in the appropriate way, even a small amount of rotation kind of cues your brain into seeing that there is rotation happening. Yes, it's matching somewhat with the physical rotation. If you remember from the car example before, I was giving that you can do some quite dramatic things there. So as long as you're giving them some kind of cue that it was rotating in the same direction, then they were okay. So they didn't get motion sick when you did that small amount of rotation. So that worked quite well. Very simple for kind of window display. Just rotate it a smaller amount. We looked at how much you have to do. If you don't rotate it enough, it isn't enough of a cue for your eyes. If you rotate it too much, it disappears from view. So there's a kind of sweet spot. Then the next one, this work was inspired by the fluffy dice that you have hanging down from the rear view mirror in your car. So in this case, we call these physics-based cues. So those dice give you a very strong cue of the physics that's happening. When the car turns, they swing backwards and forwards. So you can get a lot of information from those about the actual motion of the car. So we created a simple version of that with some red balls on strings hanging down behind the task that you're involved in. So again, here there's a maths task, and as the car turns, I'll show you actually it's a bit better on the next video. So as the car turns or the seat rotates, the swinging balls rotate to give you some matching feedback. So the idea is they're behind the content you're working on so that they don't distract you too much, but there's enough that your eyes can see there to give you some physical match, visual match to the physical motion that you're experiencing. Which worked very well. Then the last one was we tried something, again, physics-based, but then based around acceleration. So in this case, what we do is create a star field display around you. That's the little red dots in this picture. And then you're watching a movie in the middle, and the stars in the star field respond to the acceleration of your vehicle. So it's James Bond with Madonna and Pierce Brosnan. So you're watching that, but around you, outside the center, you can see these red dots moving. So the red dots only move when the vehicle changes acceleration. Previous work and our own work, we'd had them moving all the time. A bit like you're flying through hyperspace and you're seeing the stars shooting past you. But actually, that's not how your body perceives motion. You mostly, with your vestibular system, are perceiving changes in acceleration rather than constant motion. So if you only show the acceleration, there's much less visual stuff happening all the time, and it's much less distracting. So we compared this to a more typical one where the stars are flying by all the time. Now, what you're seeing in this picture is a lot of acceleration and deceleration to show the effect. But a lot of times when you're just driving at the same speed, those stars don't move because you're not really changing speed, like on a motorway. But and you don't get sick in that situation, really. The sickness comes when you're making changes in the speed. So by only showing the accelerations and the decelerations, we remove a lot of the distraction, but give your vestibular system the kind of key things it needs to be able to deal with the motion sickness. So all of those three ones I showed you there, they all significantly reduced motion sickness. Now, you might imagine using those in different kind of situations. Some of them you could combine together, some of them you might use separately. The acceleration cues were as good as kind of presenting constant velocity, but much less distracting, for example, because you don't need the velocity information because your vestibular system mostly perceives changes and not constant movement. So by applying some of those, then you could put them around other content. So if I'm working on a Word document, I could have those stars around the edges of that, and as the car turns, I can just move the Word document slightly. For the swinging balls one, what we did in a later one was we used in a snowy scene, we had the snowflakes moving around, or in a sandy scene we had like sand grains blowing around, but they would just blow around in the way of the car motion. So you can kind of integrate them more into your VR experience, so that they're even less distracting and they appear part of the whole scene. So let's think about a few conclusions. So we spend a lot of time as passengers. Every day maybe you're commuting to work, and that might be quite boring. Maybe you're taking long journeys like me tomorrow, flying back to the UK. Now I've got 11 hours of plane flight. Maybe I can use that time more effectively. Maybe instead of watching the movie on the seatback, I could have a screen this size. And that would be much more immersive and much more exciting than watching just a little screen. So we can use the VR and the AR for entertainment. As I showed you some examples of gameplay, we can use it for work. So I can have my multi-monitor setup that I would have in my office. I can create that in the back of a car or on a train. And then I can collaborate with people. So oftentimes people say, oh, well, if you're in AR or VR, you're cut off from everybody else. But actually we can share those VR environments and collaborate and be with other people in those, playing games, working or whatever. So that's entirely possible. But there was these challenges. No matter what kind of transport you're in, you're always in some kind of confined space. Even if you're in business class on your flight, you've still got a confined space. But certainly in economy class, if you're in the middle, it's a set of 5 seats and you're the guy in the middle with 2 and 2, you're not really going to get out and do too much stuff there, not going to move around. But maybe I can escape some of that by presenting this different kind of virtual world. But I have to think about the fact that I'm in a confined space because I can't start doing movements into the person space either side of me because that's going to make me unpopular. And then there's this whole issue around social acceptability, about the types of interactions you can do and where you place the content. So you might think, well, I'll place the content just wherever I like. But actually people didn't want to do that. They had places that they would like to put it and that they wouldn't like to put it. So developing any system like this, you need to give people a lot of flexibility about the type of input techniques that they use and the way that they can configure their displays. And then underneath all that was this issue of motion sickness. We know that's a problem right now. Many people get sick in cars and trains and other things. So we don't want to make that worse by using virtual and augmented reality. But because we control a lot of the pixels they see, we can use them to our benefit and use some of those pixels to reduce the motion sickness. So by presenting stars around the star field, by having something else behind the view that you're looking at to indicate the physical motion of the vehicle. So you can do some very lightweight things, but had a big effect on people's motion sickness. So what I'd like to say is that that can then unlock the potential of this travel time in the future. We can now use our travel time for more interesting things, be more flexible in the way that we do that, watch movies, do work, be with other people, and hopefully our project has laid the foundations for some of that. So with that, I'll finish. Of course, I did this project with many other people, some of them listed there. I would say that this kind of project, the ERC project that Marco mentioned, if you have the opportunity to apply for it, it's fantastic. Gives you money to do projects work over a longer period of time to really attack some interesting and big problems. And if there's any students in the audience who are interested in coming to visit Glasgow, we're always very happy to host students. Come and talk to me. But with that, then I'll finish.
Thanks a lot, Steve. Questions? I'm pretty sure you have plenty of questions.
Thank you very much, Steve. I have a quick question on the conclusion. You were separating entertainment, work, and I don't remember.
Collaboration.
Yeah, exactly. So did you do a slicing of that? And I was wondering, like a kind of, in work, for instance, could be reading or typing, or also it could be related to interaction techniques, like I'm doing indirect manipulation, like clicking on button versus dragging and dropping. So did you see differences?
So we looked at a lot of those things. For example, if you remember the passive haptics there, we were looking at tapping and dragging and making better interaction techniques and using the advantage of the fact that you've got these physical surfaces around you. So we use those. Right, I forgot what was the first bit?
Work is very broad. So
yeah.
Did you do some slicing?
So for work, we were thinking about screen-based work. So editing documents, things like that. So rather than, I don't know, using a hammer and a screwdriver. So it was work where you'd need to have windows, because those are the things that cause problems. If you stabilize the view, they can cause the problems with motion sickness. And then for gaming, you can imagine you also need windows. Okay, of course there's some fully immersive games, but many games designed to run in Windows, so they would have the same kind of issues.
Hi, Steve. You mentioned this question of social acceptability. And do you think that the evolution, the technological evolution, can help to better address this aspect, or more or less we have reached the
I think
limit?
there's some interesting things there. Has anyone used Apple Vision Pro headset? So they do the weird thing with the eyes in that headset, so that the other person outside the world can see your eyes. Does anybody like the eyes? It looks totally weird. So they tried to do something, I think, to deal with this issue of, well, is he in a virtual world, or is he in this world? But they did it in a way that's like, no, that's weird. So I think we could do things, and of course, maybe eventually my AR headset is just these, and I just tap on it and stuff happens, in which case it's much less obtrusive. Right now, you're wearing a big bulky headset which cuts your eyes off from the rest of the world. But I'm not sure that Apple's first solution to that was super successful.
Okay, thanks, Stefan, for your presentation. It was very inspiring. You treated about many aspects of using VR in small places and so on. And there is another one. The head-mounted displays nowadays are still heavy and uncomfortable, and experience should be short.
Yeah.
What do you think? Do you have some thought for the future, or how to solve it?
I think many of those problems will be solved over time. So if you think back a few generations, it was even heavier and more uncomfortable than it is now. So I think they'll get better. A lot of companies are working on that. People are working on new visual displays, all sorts of things. The processing power is increasing so that you can do more in the headset. So I think many of those problems will go away. Eventually, I'm sure Apple's view of the world is that, yes, these would be my AR glasses, and I wouldn't need anything extra. And then many issues go away. But some of them don't, because if I'm using these and I'm staring at you for 5 hours, that's still weird. Maybe it's even more weird. So there's still those kind of social issues of using those headsets, and part of it is being, I'm in one world, but you're in a different world. So I'm doing things in my world, but you don't know what I'm doing. So it seems strange. So how we could deal with that part, I don't know. That's more difficult, because you are kind of separating yourself. But you could certainly make better solutions than what Apple has tried to do so far, I think.
Yeah, but for you, the solution are headsets.
So we've been doing work on audio augmented reality, where we're just using regular earphones. So you can do a lot without the visual display. But if you want a visual display, then yeah. Now, maybe you could do things with projection and other kind of things in the environment, but mostly, if it's like my phone, I'm taking all of my stuff with me to wherever I go. So I think Apple's view and Meta's view would be, well, you know, the phone becomes a headset, therefore I'm taking that headset with me with all of my things on it, rather than going into some environment where all the walls are projected. But there could be some of that, but I think most of it is personal.
Okay, thank you.
Yeah. Hi, Stephen. Right here. Yeah. Nice, interesting talk. I really enjoyed it. It made me think about the 3D cinema, and which makes me think I should ask you, how do you draw the parallel with people watching 3D movies in the cinemas? Because the work might be very relevant, because in cinemas you are sitting next to each other, and sometimes people can get animated as well and also disrupt your space. And I also want to add a bit on the last question. I was at ICMI last year and I met Yasser Sheikh. He's the Meta Mixed Reality Lab chief scientist, and he mentioned me about, because I asked him the question about the headsets being very large and bulky. The long-term vision, as you rightly pointed out, is that your glasses, the one I'm wearing or Stephen is wearing, would become the headset. And yeah, but I just wanted you to reflect a bit on the parallel between a 3D, because eventually we know that 3D TVs didn't work. They were a failure, and so I believe the 3D cinemas were not very popular as well.
Yeah, I mean, well, if you think of how many generations of VR have we had, I think we're into the third generation of them now. You know, they started off, or maybe even in the 60s were the very first ones of those, and they've tried and then they've failed and tried and failed. Maybe the one that's the generation we're in now, there's more investment, and it seems to be still getting some traction. So there are some games which are, you know, they've been driving the sale of VR headsets, but I don't think yet many people buy VR headsets for work, for example. That was one, if you look at, again, not to keep going on about Apple, but one of the things that they did push with the Vision Pro was that, yes, it can just replace the screen of your laptop and give you a bigger screen. So they were kind of pushing in that direction, but I think most people really only buy those headsets now for gaming. And when we talk to people about what they wanted to do in VR, they always said, oh, gaming, because I think that's the only thing that people are exposed to. But if we can get enough people using them for gaming, then there'll be enough headsets around, and then people might think, oh, maybe I could use it for something else, and then use it for work. We have worked with some other companies that have tried to do things for work, but yeah, I think it's hard to persuade people that they want to work in that. But it's possible, and if you can suddenly have a large screen, then it really makes a big difference. You know, if you've ever used one of them to work, it's really actually very convenient, because you don't have to have any physical display. But I think, yeah, a bit of marketing maybe will get us over the hurdle this time. Many of the hardware issues have gone away. You know, latency used to be a big problem. Mostly that's gone away now because the headsets are fast enough. So. Yeah, I've not seen so much comparing those two things. I guess mostly right now the VR is just an individual experience. So most people are using VR in an individual way. You know, there are some examples of collaboration and Horizon workrooms and all those kind of things where you can be with other people, but there's not so many. All the games, you know, they're mostly you're there on your own. So, but yeah, hopefully it will be more successful. Yeah, we all went to 3D movies and then just disappeared, and we don't go anymore. No one talks about it anymore.
Hi, Xinhui from TU Eindhoven.
Yeah.
I found your talk very inspiring, and especially I saw like extent from the virtual reality. You were trying to use the passive haptic to gain more feelings and extend the world from the visual. So I was also wondering, I start to inspiring myself, like what can we do in such confined space, for example. Have you tried, or like in the future work, considering maybe wear a haptic vest or put something on the chair so that it will give you more rich interaction, like from different aspects? And also, that also reminds me, in Universal you have such experience, like it turns a little bit, but you actually experience the whole story. You are turning, you are speeding, reverse, so that if we try to, like not get rid of it, but to get out of it and extend it in some other senses.
Yeah, I mean, a lot of my work is in the area of haptics, so I'm very keen on trying to include haptic experiences here. Yeah, so, well, if we go back to the cinema example, you can go to what they're called in Netherlands, but in the UK it's 4D cinema, where the chairs move and they have vibration actuators, water sprays. Yeah, so you can do those things. You could wear a jacket with haptic actuators in it. Those are available for gaming and things like that. So if you wore that, you could do even more. But I guess the most basic situation is you're just sitting in a regular chair without any extra features, and you're just wearing your normal clothes. And then from there, yeah, you could do more immersive things by having more haptics. And of course, with really good quality 3D sound, then you can also do a lot with the sound part. So you could do more immersive things by using more senses, absolutely.
Hello, Stephen. I'm here. I'm Leandro from IFMS Brazil. I have two quick questions for you. The first one would be if you imagine a real-life scenario of a car accident or something that would catch people's attention except of the VR experience, and how would the solution be, or how would you inform about this? This is the first.
Okay. So we haven't thought too much about car accidents. I mean, so we did think about the issues on planes. So the only thing we've done in this area would be with a plane. So for example, if you're wearing your VR headset and you're in the exit row and plane was on fire, people wanted to get out, but you're swimming with some dolphins and it's all nice. So there's that link between the real world and the virtual world which can be lost. And sometimes you need to know about the real world. So maybe if you were about to have a car accident, it could cut the display and then give you the pass-through so that you could see what was happening. But I have got a lot more to say there. We didn't really think about that so much, I have to say.
Yeah, thanks for that. But the second question would be if you ever measure the amount of time that people can reduce of the amount of time that they could use the device on average, like the solutions to reduce cyber sickness, if this enhanced like in hours, minutes, or you don't have this total amount? Because I am one of the cases that I have a huge cyber sickness when I'm using VR.
Yeah. So inevitably our experiments tend to be 1 hour or 2 hours in duration rather than really long ones. So we certainly see that we can slow the onset of the motion sickness so that it doesn't come so quickly. And by combining multiple ones, then potentially we can keep the level down for a longer period. There's one other chunk of work there that I didn't talk about, which is super interesting, around brain stimulation. So one thing we were looking at is called transcranial stimulation. So by doing the brain stimulation in the correct place on the head, we had a really strong effect on motion sickness, a really strong effect on reducing motion sickness. So with that one, then potentially you could go for much longer. So in that study, we did it in the lab with a lot of rotation in the chair, a lot of rotation. And we also did that in the car with lots of backwards and forwards. And that was really successful. We just published a paper on that. So combining the neural stimulation with the visual cues, maybe then we could help you survive for longer. How long you could survive, it's very difficult to say. It's very personal because some people are much more susceptible than others. Depends what type of journey you're doing. A nice simple journey on the highway is probably not too bad, but if you're doing, in the countryside, going up and down and around, those ones can be really bad. So we could certainly make your life better, but I'm not sure we could cure it 100%.
Okay, please.
Okay, thanks for the inspiring talk. I've got a quick comment and then a question.
Wave your hand. Oh,
hi, over here.
Sorry.
It's okay. First, a comment. So I do use the Apple Vision Pro on flights,
Yep.
and I think the flight attendants are well able to kind of look at me through my big googly eyes and give me a hot cup of coffee and not really worry about it, right? It seems to work, right? My question is related to that. Actually, you mentioned that, in terms of social acceptability, in-air interactions perhaps less socially acceptable in tight quarters. I mean, there's the obvious problem of moving your hands into somebody else's personal space. But if I'm consuming passive media, I might be doing a little bit of scrolling, I might be just doing a couple of taps. It seems less obtrusive to me. Am I missing something? Is there something else about in-air interactions that make them less socially acceptable if they're confined within that space?
If you're within your own bit of space, then I think that's fine. But if it requires things which are in somebody else's space, but there's still, we call them physical intrusions, where you're physically moving into someone else's space, and we also call them gaze intrusions. So that's where I'm looking at somebody, or I'm even looking at what appears to be their seatback, which is still kind of annoying for you. Now, maybe you're not doing that because you're in VR, but it's hard for the other person to know what's going on because they can't see what you're doing because you're in that different environment. So I think there's many things you can do. And if you're just watching a movie, then, yeah, you don't have many interactions to do, and I can just be laying back and watching that movie. I'm not really intruding into anyone else's space. But if I've got multiple monitors and one of the monitors is over here, then I'm starting to get into space. Or even if I'm sat, if I'm sat in the left-hand seat and the wall is here, well, I can't get into that space anyway because that's where the side of the plane is. So I need some different interaction technique which will allow me to get to the things over there that I can't physically reach. So I think you can design ones that work totally fine. Movie consumption, passive consumption is probably a great starting point. Did you use it with the display for like edited documents and stuff like that?
I tried, but I couldn't get it to connect with my laptop. Right?
Yeah,
so,
yeah. But potentially that allows you to do some of the things I've been talking about if you can make it work.
Okay, we are right on time for thank you again, Steve. It's always inspiring to listen to you and let us to dream about a different way of interacting with the world. So thank you very much.
Thank you. Thank you for inviting me to talk.
Thank you to Stephen here for a great talk from the organization here. Any more news about the fact that previously, I think we went to another hotel that somewhere we got to start practicing this is handy. Please let me know. I think you'll have to go WhatsApp. Please keep us posted. And if you need anything to take do let us know. We'll be around there. My hotel is about the stone throw, so very good to get there.
Perfect. I'll go and sit down here for now.
Okay. We were going to call you. So we start,